talk about this session, the importance of observability and a multi-cloud ecosystem. This is a great panel hosted by Grant Linehan at Appledore Research, and it features speakers from MITRE Lab, Tantra Analyst, Rakuten Symphony, and Red Hat. And right now, I'm going to hand it over to Grant to kick off with his panel.
Well, thank you very much, and welcome to everyone in the audience across various parts of the world. And I do want to, give a real shout out to the panel we have here. In our prep session, it was obvious that everyone on this panel has pretty deep knowledge about this area, often hands-on knowledge, often hands-on architecting and writing code and recommending how to make things work better. So this is going to be a group of experts. I also would encourage you, if you have questions, to ask them at the end. A quick introduction, we have Venki Ramaswamy from MITRE. We have Prakash Sangam from Tantra Analyst, who also has written for a number of other publications. We have Sree Atur from Rakuten Symphony, and we have Fatih Nar from Red Hat. So operators, virtualization vendors, analysts and advisors across the board. I'd like to welcome the panel and start out with just a quick comment on observability and then turn it over to one of our panelists to begin talking about this. And really the question is as simple as this. What is observability? But more than that, what makes it new and different? Specifically, what I'd like to do is have the panel address the question of what problems are we trying to solve, and how would you characterize observability in a going forward sense as opposed to a looking back sense? Venki, would you like to kick that off?
Sure. So the observability, the idea of observability is nothing new, right? I mean, it has been around for a long time. Myself, I'm a control theorist, so I have dealt with this for a very long time. The idea is that if we assume, or if you consider a network as a system, how can we gather information about the internal state of that system just by observing what is happening in the outside? So that's the basic idea of observability. How much can you gather information about the internal states from external outputs? And the example that I typically give is that when you go to a doctor's office for any health reasons, right? So first thing that they do is take your vitals and your blood pressure and your weight and things like that. And then they try to stitch together all those information. They integrate that information and try to infer what is happening. That part, right? How much can you infer? How much can you diagnose the underlying problem? Is what is really the observability, and all the measurements that you take, all the vitals that you take, you can think of that monitoring and data collection. So that is the key difference between observability and the typical monitoring collection systems that we have. Now there is another concept that is very much related to observability, which is controllability. Right? I mean, the reason why you want to observe is that you want to be able to do something on the system to get to the level that you want to achieve, the kind of outcome that you want to achieve. So the reason why we do really the observability is to be able to control the system in a way we want to achieve. This has been around for a long time. As I said, monitoring, people do monitoring. People do data collection for a long time, but the difference now is that the systems that we deal with is extremely complex, very diverse, and the tools that we have used in the past are not going to suffice anymore. And so we need to be able to see across these different platforms, different protocol stacks, to gather a holistic picture of what is happening inside the system. So that is the challenging part, and that is what we are going to talk about today.
Thanks. And you learn something new about the panelists every day. A control theorist. I wouldn't call myself a control theorist, but I spent a remarkable number of disconnected times dealing with feedback and control theory through my career. So it's interesting to hear that. Sree, I know you have some complimentary views on this that you wanted to add. Would you like to pick up there?
Yeah, sure. So to understand observability, we need to understand the three core pillars of it. It starts with data, insights, and action. You can think of these as the three vertices of a triangle and arrows going from one vertex to the other. You start with the data, you derive deep understanding of the situation, which are called insights, and you take some action which produces more data, and so on. Now, with data, let's understand the components. It starts with the source of the data, like who is producing the data. It is infrastructure, cluster, and applications, and the network. And the format of the data, it could be based on different 3GPP standards and compliance. And how is this data enriched with the other sources of data that is coming in to be able to process it better, either in real time or doing a historical processing. And once you have this large amounts of data, you have to think about how do you store it and how do you rotate it. And when you store it, becomes important as to who owns this data, the data ownership and governance and audits. And the next part is about insights. So what actually are we deriving from this data? And this comes to FCAPs, meaning like the fault and high availability of the infrastructure cluster and applications, the health, as Venki mentioned. Then the configuration, like what is the current configuration of the network and what it was before, which is any drift that has happened. And the accounting, what is the current resource consumption of the network and what it was and what it could be from the performance point of view and security. And once you have this deep insight, you take actions. It is like a deed. You take steps which is done intentionally and consciously to either recover from the fault, to optimize the current situation, or to prepare for the fault. And then you think about resource optimization. It could be 3 a.m. in a particular geographical location, and you would want to dial down the number of resources. Or it could be a 7 a.m. or a 5 p.m. rush where you horizontally scale up and scale down the resources. And or it could be a particular point in time where when a disaster happens and there is a huge network load and the network has to sustain. Now, with all of this, what is it that we are gaining? We are gaining three important things, or the network operator is gaining three important things from the network. The first is, with everything that is data, insights, and action, there is a reduced operation. Intent is to have reduced operational expenses, which is the number of dollars saved. The second is improving the fault management and high availability, which means performance and better customer experience. The third is reduced resource usage and power usage, which translates to the dollars saved. So you're serving the network with happy customers for less the cost.
Would anybody else like to add a little bit more for any of the panelists? Go ahead, Fatih.
Yeah, these are really great points. We started with the control theory and we go into more details about a lot of data, times of volume, variety, and velocity. But at the end of the day, it's not about fully control as a control theory. It's more of a game theory. You have your ambitions and yet you have your capacity and your budget as a service provider or an operation team. So as a game theory, you have to not aim the nirvana, but you have to aim somewhere really logical by means of what data you have and what you can do with it, with what cost that you can provide the funds for. What I'm hinting is, at the end of the day, everything ties into, as we agreed, into data, collecting data, saving data, and using data. And collecting data, it needs real-time processing by means of compute capacity. Storing needs storage, and also feeding into actions may need external players, external partners. All of them has to come together as a Lego pieces. And then you see, oh, this might be really costly because the storage is too much, or this might be too costly because I'm carrying data from one cloud to another, which we'll talk later. What I'm hinting here is game theory by means of aiming what you can achieve as a reasonable team, as a reasonable objective is the I think main objective here.
If I may
Thank you.
add, I mean, we are
Please.
only talking about from a cost and management perspective, but also I think there is a component of how can you monetize it. It doesn't have to be just a cost for the organization, but if you can get insights and ensure service level and so on, and monetize it rather than just having a regular across the board same kind of service. If you can provide a tiered service, you can monetize it as well, right? It's not just a cost center, but looking at it as a way to monetize as well.
Oh, Fatih, did you want to add some more?
No, I agree with it. I agree with it.
I saw your hand go up.
I just did a thumbs up.
Well, before we jump off this, I'm sorry, you can blame Venki because he got me excited with his reference to control theory. One of the things that I've been, looking at in this area is the fact that you really have two processes going in most control loops, a fast loop and a slow loop. Because, for example, Sree was talking about collecting large amounts of data and analyzing it. And that, takes time in many cases. In fact, sometimes you're looking at patterns over time, which by definition takes time. Um, have any of you dealt with slow loops to learn irregularities or correlations combined with fast loops to act on data that you've already figured out?
Hmm.
Wondering if that's made it to the real world or just in the theoretical world.
So I would like to add here. So there are, as you mentioned, the control loops. If you're talking about 5G and its architecture, Kubernetes is the de facto platform for running the cloud native applications and the 5G. So Kubernetes has its own autopilot and closed loop architecture where it does provide some amount of assurance so that the applications are always running with liveness probes and readiness probes and other HPA and VPA to automatically scale up and scale down, which gives you resource optimization. And that is all done within the particular Kubernetes clusters. But the problem is 5G is disaggregated, right? You have hundreds of thousands of clusters which are geographically distributed, and you have its own clusters and 1,000 control loops. So there has to be an end-to-end orchestrator which will actually look at the different situations, the data across the different clusters, and does its own control loop. Now that happens with the data that we have actually collected and processed. And sometimes, as you have mentioned, with large amounts of data coming in, real-time processing may or may not work. At Rakuten Symphony, what we have seen is a decision could be taken maybe in 60 seconds or 120 seconds of the situations or faults that have happened and try to rectify it immediately. So these are some of the different control loops and service assurance models that we are experimenting and seeing results.
Okay, thank you, Sri. Actually, moving on, we were also talking in our prep about the fact that a lot of what we're addressing in observability really comes from changes in the network and operations that demand a different form of observability and the disruption that these changes bring. So I was wondering, Prakash, if you'd like to start out and say what's really different about the network, the new network technologies, the virtualization, and the operations that is impacting observability, and what might some of those top three, top two impacts be?
Yeah, sure. So, I mean, things were much easier if it was all the whole network is monolithic. It's one cloud provider, one software, and one hardware provider. Then you basically go to that vendor and get the tools. But that's not how it is in the real world. So you have, especially with virtualization disaggregation, as you mentioned, you have different software, hardware vendors, different cloud vendors, and we are in this because it's a multi cloud environment, which means there's tons of complexity in whatever you want to do because components coming from different vendors have different characteristics. So I would say the by far the biggest issue is increased complexity. And following that, all of these different vendors have different configurations. If you take, for example, different cloud providers, they have different configurations. Making sure somehow they jibe very well and and work together is obviously a challenge. And then you have multi-cloud or multi-vendor environment because you're running different kinds of loads and you selected these providers based on best of the breed, which means you have to dynamically manage the workload across these without affecting the performance. In fact, providing the best possible performance. I think that's the issue when you have a heterogeneous mix of systems. And of course, when you have these many different components, interoperability is a major challenge. And then in terms of course, there is always a security challenge. So you have to have common open APIs so you can work together. And also, more and more, rather than relying on the individual vendors who provide these systems for observability, you basically get the APIs and stuff from them, and then have a third party likely develop vendor agnostic tools to look at the network holistically, as you mentioned, in a slow and a closed and slow and fast loops, and make sense out of it, whether the underlying systems are open enough to make that happen. I think we're not there yet, but that's actually at least the wish list from the operators and the providers and so on. So I'll stop at that.
Yes, go right ahead. Thank you.
Yeah, sure. So I agree with Prakash. So I think the couple of things that I see is that the disaggregation that is happening, right? The software and hardware disaggregation, control plane, data plane disaggregation, as well as management plane disaggregation, and moving our workloads to cloud, right? The problem is that when you move our telco workloads to a public cloud, you are now sitting in somebody else's infrastructure. I don't know what is happening there, right? I don't have a lot of control there when the my workload itself is sitting on a public cloud. So that is, I think, a huge challenge for many of us, where we don't have, even though we have some tools and things like that, we don't have quite the kind of tools that we are used to work with, or quite the control that we are used to. The other point that I would like to mention is the dynamism, right? With cloud, you are able to spin up, scale up, scale down virtual machines very quickly, which means that you need to have these observability control loops in the order of milliseconds. You need to be able to get the right data, get the decisions in the order of milliseconds. So it's in many cases, it's at least either real-time control or near real-time control. The old-fashioned offline learning and non-real-time control is just not going to be sufficient in these cases. So those aspects really make a big difference. And I would also like to add what Fatih told us before, right? We have a lot of data, but the point is that if you are having to go through all this data that you get for free in many cases, it creates a lot of burden. What is the right set of data that I need, right? I need to diagnose something. I don't want to be overwhelmed by the data that I get from everywhere. So you can get terabits of data. What am I going to do with it? So figuring out the right set of data, sending it to the right node to make a decision, that Goldilocks scenario where I get the right data for the right diagnosis, the right observation, is going to be the key.
Question off script for a moment is, how do we as an industry start capturing those learnings? I mean, that's something that you will learn in part through experience. And while everyone says, wow, I've learned it, I want to exploit it, the reality is there's dozens and hundreds of us out there that probably ought to be passing information on. Have you experienced it? Have you seen problems doing that? Do you have words of wisdom? And I can see that Fatih is going to tell us how to do some of this, because he's nodding and smiling.
Yeah. With the nature of the telecom domain, right? Telecom media entertainment vendors used to be, and some of them still do, is to be keen of having closed data formats, closed, unshared proprietary protocols, sharing that data with their systems for analyzing, collecting, and storing. And that was a challenge, and that was actually blocking the way of multi-vendor ecosystem. With the power of open source, obviously the last 10 years, it started with the OpenStack, and we went into the now Kubernetes with the additional surrounding open source projects. That is enabling us to collect data from multiple points, as it was hinted that 5G system, telecom systems are highly distributed systems, but yet with open source, we can collect data in an open source way with open protocols and process them, store them in an open source project, say Prometheus, say Panos, say InfluxDB, and process data, say with Hadoop and Spark, and then turn into a workflow. Yet run everything on top of Kubernetes, which is a declarative platform itself. It kind of maintains its status and observes itself and fixes itself. What I'm hinting is, as the original question was, Did new ages or last few years, did we witness any change in technology that is shifting this observability domain under operation support systems? Yes, we have been observing it with the power of open source. Now we are using and contributing heavily with open telemetry. Open telemetry is a way to instrument applications to create metrics, events, logs, and traces, and share it with the platform. Platform stores it for you, say in Prometheus in open source backend, from where you can export it wherever you want to export for data crunching, data visualization. So long story short, the power of open source ecosystem is empowering and the success of observability in our age.
Anybody else want to comment on that? Or have we covered it sufficiently?
Yeah, so I would just like to add that there are initiatives and efforts that are going on to come up with blueprints of how to do this in a system. One of the things that I'm aware of is what TM Forum is doing, open APIs and things like that. So that is probably another thing that could add to the distribution of learning, right? I mean, we have people like Nandan and others who know how to do this one. How can they kind of create an opportunity and share the knowledge? So that is, I think, an opportunity where we could all contribute to.
And in fact, on a service and technology specific basis, I was just down at the MEF NAS event, Network as a Service event. And what I like there is they're taking the TM Forum open APIs and driving, particular data formats and needs in to manage known services. So they're getting, practical down to where the rubber meets the road, which I always appreciate because it focuses the mind quickly. There's sort of a flip side to the what are the changes in the technology that are driving observability. And I know that Sree wanted to comment on, what have the limitations been of current practice and past practice? And if you can, also any opinions that you have on how we can upgrade that, because there is always a lot of old technology in a network. And just because some of the technology isn't coming out, that doesn't mean we can't improve our practices. So Sree, if you'd like to kick off the discussion on what have our limitations be and how are we addressing that?
Okay, so I think as Fatih and Venki mentioned, there was between the 4G and 5G, the intent of the architecture has itself been better with 5G, right? So you have higher data rates, lower latency, increased capacity, more number of devices connecting to the network because of the bandwidth. In 4G, it was all about mobile phones, and in 5G, it is not just mobile phones. You have laptops, you have IoT devices. It is oil and gas sensors, pressure sensors. It could be billboards and petroleum and gas sensors, etc. Right? So you have tons of devices producing tons of data, all connected to the network and operating. And because of this, there is huge number of data that is collected, and it all happens because of the 5G bandwidth and capabilities. Now, as Venki and Prakash were saying, there is disaggregation, and it happens both on the hardware side as well as the software side. In the hardware side, the gear is more towards Open RAN, wherein you can operate the network with commercial off-the-shelf servers. And the software disaggregation comes in terms of the RAN software itself, where the RAN is broken down into multiple components like RU, DU, CU, core CP, and core UP. And the third disaggregation comes in terms of splitting the CU into the control plane and the data plane, and the user plane, and the DU and the CU connecting and working together and sharing the same state and operating efficiently. Now, in the 4G, there were fewer layers of the edge stack, but in 5G, because of the bandwidth and capabilities, you have multiple layers of the edge stack. It starts off with the far edge, where you have hundreds of thousands of far edge clusters connecting to the actual RU, maybe with a radius of 10 kilometers, and it is geo distributed. And all of them connecting to the edge clusters where the CU, the UP and CP runs, and then it connects to the core network where your core software and the orchestrator and other control plane orchestrators run, and then it connects to the MEC. So you have different layers of the edge stack in 5G, which is quite different from what it was before in the 4G. And obviously, you have different tiers and different layers of the stack producing different amounts of data, which all needs which adds on to the complexity and the needs for management.
If may I add, I think the
Sorry, yes,
biggest
I knew
change.
you had some things you wanted to add to that. I was muted.
No, sorry. Yeah, so I think the cloudification across the board, vertical and horizontal, in the telecom systems, I think is the biggest change that industry has seen, which is which will ultimately, which is now and ultimately in the future, affect observability. I know you have lots of legacy systems and which are not cloud based. Now the new ones are coming, which are cloud based. So how you manage observability, not just for observing, but if you want to provide a consistent service level agreement, SLA level tiered service, tiered performance service, how you ensure between the legacy and the new cloud based whole system, I think is a major challenge that every operator is kind of grappling with, right? And with 5G, right now it is primarily broadband connectivity. But if you look further, when you have to provide different kinds of connectivity, how do you ensure that the service levels across these are maintained when you have new cloud-based systems and as well as legacy systems which will coexist for a very long time? I think that's been the biggest challenge.
Okay, like to comment on that?
Yes, please. So if I flash back quickly, the observability is capturing the state of your application stack, how it is performing, is doing well or not, collecting the data. This point is, what if your application could be a legacy application? Maybe the data that you expect that application is not being generated, that the observable data is not being generated. What you gonna do? So you cannot go back and ask, hey, rewrite this code or auto instrument your code. Maybe the code is not available. It's just the binaries. So what you gonna do? So what we have an answer for that from an open source role, which is if you heard the word eBPF, Enhanced Berkeley Packet Filter, which is running the traces and collecting data in the Linux kernel for you for the processes running on that particular host machine. So we can create application observability data without application, with legacy application running on that Linux host, being aware of that data is being collected. So we have answers for you. If you want to go full cloud native observability data collection generation, we have Open Telemetry Framework running on OpenShift, for example, on Kubernetes. If you say, no, this is an old application, yet it is lift and shift, we package the binaries, looks like kind of containers, but in essence, it's actually a virtual machine. Who knows? And then we can still create that observable data for you using eBPF technology as a part of the platform and give you that data accessible to be used. So we have answers for that problem.
Venki, go ahead.
Yeah, so I'll just be very quick. Others have just pointed out pretty much everything that I wanted to say. So there is also a difference in the focus, right? So in the older generations, what we have seen is that the focus was on single elements, network elements, right? And that's why we have things like EMS, element management. It's always the health, the observability related to one particular element, one particular silo. We had this, what I call as islands of observability, but the focus now is more on customer experience. You don't care whether something is good or not. Finally, what you need is the experience that the customer is facing. So the focus has shifted from elements to customer experience.
Agreed, and in fact, you've got also the problem that we used to deal with network functions that pretty much either worked or didn't work. Virtualization, cloudification is the gift that plays both ways. It certainly complicated our life, as we've been discussing, but it also gives you the ability to actually resolve problems, at least temporarily, while the real underlying cause is found. So you do need to have two different paths going. The how do we fix it, and how do we make sure the end customer process is not affected. While we're maybe sending out a technician, because there are things that still blow up. And actually, when Fatih was talking about getting data when the application was not providing sufficient richness of data, that's a really nice sort of bridge to the next topic that we had all discussed, which is the complexities introduced, but also potentially the opportunities introduced as we create multiple layers in a stack, from hardware that needs to be monitored and has limits up through the middleware to the end app workloads, and then the network functions that are created from those workloads and databases and whatnot. Uh, Fatih, you brought it up. You might be a great one to start leading this off, and then all of us
Yeah.
can jump on top.
So let's back to my game theory approach, right? What do you want to achieve with what money and what resource, what is the main rules of the game. Some people say I have limited time, limited resources, and I want to focus on application layer observability. So if you're focusing on top layer of the cake, application layer observability, you think that the rest of them being handled by platform teams and SRE teams who are dealing with the infrastructure platform on multiple infrastructure types, fine. You say, I'm an application SRE, I only focus on application observability. But the reality for telcos is not like that. For telcos, there are network operation teams covering the full cake from application, platform, infrastructure, network, per geolocations. This is the reality. So when I was part of one of the big ones, say Verizon, that's the full like there were not many people dedicated per CNF or per platform. No, the network operation team is a network operation team. So then what you deal with, okay, I collect data from each layer, application layer, say 5G core, platform layer, say Kubernetes, and infrastructure layer could be, say, bare metal, or if you're running on cloud using cloud APIs to collect data, then you have to do correlation of this data with like a data mesh. Now the big topic, right? In 10,000 feet, then data mesh is data correlation. You're tying all these data correlated to each other to deliver a storyboard, how these data are related to each other for root cause analysis, performance management, service assurance, and so on and so forth. So when you increase your scope, i.e., from single layer to multiple layers, from one infrastructure type to multiple cloud, complexity becomes really unbearable. I lived through this. It's a hell. It's really tough. And most of the time, it's impossible to do the proper RCA on time. So what can you do? So you have to lower your complexity. It's 101. Lower your complexity. How can you lower your complexity? Okay, I got a lower number of APIs I'm using. So I'm gonna have an OpenShift API to deal with the bare metal, performance metric collection, Kubernetes data collection, as well as free open telemetry data export from single API. So you lower the 4 layers of complexity into 1 layer across multiple infrastructure types: on-premise, virtual private cloud, AWS, Google, and so on and so forth. Everywhere is one horizontal layer, single API access, lower the complexity. Now, you can drill down into specific application metrics and logs to find the root cause analysis. Say, why my GNOBs are not getting properly registered on time. Let me look at AMF logs. Oh, this is because SCTP load balancer is acting not good enough or performing. Now we are getting somewhere better with the same capacity of people. Long story short, to have a better SLA tied with the observability empowerment, better operations, lowered operational expenditure, lower the complexity of your solution architecture across multiple infrastructure types. Thank you.
Excellent. Sree, would you like to pick up on that a bit?
Yeah, I would like to touch upon the complexity part that Fatih mentioned here on 3 different angles. So the first angle is that the complexity of the 5G network itself. So you have the RU, which is actually absorbing the radio waves and translating it into electrical signals and passing it down to the optical wire, and that goes to through the front haul network onto the forage clusters, which are geo distributed, which is the where the DU runs. Now the DU processes that data, and it has to do so really fast. And instead of using CPUs, they use something called accelerators, and it could be either an eASIC or FPGA or even GPUs. Now, once that data is processed, it has to send to the CUs, and that goes through the mid-haul network. And the CU processes that data and then passes it on to the core using the backhaul, and then it goes on to the internet, right? Now, this is the first layer of complexity. The second layer is as Fatih mentioned, the infrastructure itself it could be different. Some of it could be on-prem, some of it could be on the cloud. For example, the DOCU could be on-prem and the core could be on the cloud. So you have the data is actually going through different layers of the network. And the third angle is that the software itself that is operating on the data on the front haul, mid haul, and back haul could be coming from different vendors. Although it is not common, I mean, the architecture specifies that. I don't know if it is practical, but the DU could be coming from Samsung, the CU could be coming from a different vendor like Nokia, and the core could be coming from Veneer. The architecture specifies it, and there is a way to provision it to make it flexible. That is the whole concept of Open RAN. But you have different vendors or different software providers who are actually operating on the data. So that is the third complexity, the third angle to the complexity that Fatih was mentioning.
Venki, did you want to add?
Yeah, sure. So talking about complexity, I would also like to add one more layer to what Nandan was talking about, right? So you also have complexity at different domains. You have the RAN domain, core domain, you have the application domain and things like that. In 5G networks, there is something called as NWDAF, data analytics function framework, that is in the core domain, but it collects a lot of information about the application, right? So it's application well as network functions that are in the core. And now you have NWDAF, you also have the management data analytics function, which is looking at all your FCAPs and things like that. And then you have what Nandan was talking about in the RAN domain, right? So you have everything that comes with and all the analysis and all the data that you can collect at the RAN domain. So you have three different domains, and within each domain, you have multiple levels of complexity, and these are all operating at different timescales, different kind of data that they ingest. You have the complexity at the core that you can imagine. So dealing with this is very, very difficult. And in many applications, we actually need stitching these things together to get the complete observability. One of the examples that I usually use is mobility, right? When you are actually moving from one cell to another cell, not only do you have to consider the aspects of the user, the cell site, with respect to the mobility pattern, you also need to take into consideration the applications time window, right? When is the best time to actually move a user from one cell to another? That may be dependent not only on the user's mobility patterns, users' activity, but also on the application's state. So taking into consideration all these different aspects is very important, but it also comes at a very, very huge cost and complexity.
And also who owns and who governs, who manages data becomes very critical as well. If you have single stack and single vendor, they have governance and data management responsibility. If you have multiple vendors, of course operators own all of the data at the end of the day, but for decision making, at the different levels of the network, how that is exchanged, who ultimately owns and then uses that data becomes important and critical and need to be defined as well.
Okay, we're coming along toward the end, so I think I'd like to move us along to the last question that we talked about as a group, which is looking at really the same question we just asked, but rather than looking at the multiple layers and the complexity and opportunity that brings in, looking at multiple clouds. I mean, the reality that we're going to have things in private data centers and in one public cloud and another public cloud, possibly different technologies in many of them. And how do we deal with that? And I just wanted to give you a heads up if you haven't seen it. Mohammed asked earlier on specifically about this. And, would there be one place for remediation in multi-cloud environments? I sort of held off answering the question because I presume we're going to get there, but it's worth knowing that we have a viewer that's interested in that particular question. And if we could maybe have Fatih kick this off, and as usual, please, everyone feel free to join. You're muted. You're muted.
Yeah, sorry. So I muted myself to avoid the noises. So let's start with the last point, which was the data governance. Who owns what data and how to share that data, how to transmit that data, and how to store that data. So there are two critical aspects of the security for data. Data security at rest, data security at transmit. And now you're dealing with multiple cloud. You're crossing many boundaries with that data. If you are, you're subject to security rules and enforcement, as well as network egress and ingress charges. So transferring data is not free across multi-cloud. Okay, so I see a lot of companies struggling with that. That's why I kind of pointed out. So when you come to a challenge with the cloud for observability, can I have a solution that can foresee different infrastructure types and inside those infrastructure types collect those application observability data and show me from a single pane? Yes, we do have a solution and some other solutions also available. The open source name of the solution is the Open Cluster Management. Although the name says cluster management, it does collect application data, offers application placement over multiple clusters, multiple infrastructures, as well as offer you the CPU memory storage level observability data. Now, this is an observability data that is coming from infrastructure, platform, from different various locations, infrastructure types. The application data itself, as hinted before, application, i.e. the business domain. Here we are talking telecom, media, entertainment. Let's deep into a little bit more. 4G, IMS, 5G, domain expertise with that application data is where you will shine with what you can do with that data. You have to bring your expertise of that particular domain, use that data, create actionable workflows so you can create either insights or do AI-driven operations or monetize that data, application data that is tying to domain expertise that we provide as a platform tools and all the frameworks for you. Thank you.
Who else would like to add on this?
I can add, I mean, more from a ecosystem system point of view. I mean, historically, the observability, all the insights would come from the vendors' own tools, and each one had their own tool, and operators had to manage those different tools and try to correlate their data. But now with with open systems, I think there is a role for a third party players basically looking at providing these tools which work across all the vendors and make it easy for operators to manage it.
Anyone else? One thing I wanted to ask is we've talked a lot about the complexity and how we need to correlate across multiple layers, sometimes across multiple workloads and network functions in a complex service chain. Uh, to what degree have, particularly those that have hands-on experience here, found that some of the deterministic things that we still have remaining, for example, where a workload is operating should be kept within the middleware intelligence. To what degree is that useful, and to what degree is that an interesting concept but has some flaws in practice? And anyone here?
I talk too much. I'll let my friends talk a little bit.
Good opinions are good opinions.
Yeah.
I mean, one of the reasons that I ask is we have a client that we were working with that was counting on using that data to deterministically associate hardware with workloads so that you could at least say, look, if this failed, we know this is going to be impacted. Maybe the other way's harder, but at least we know this direction is impacted. And they found there were some delays in some of that information because of the collection from the hardware, right? So they were actually making a false correlation. Now, I presume that's fixable with delay, getting real-time data and nearer real-time data. But I was personally very interested having two people that have built and operated these things in anger, as we say, here on the call, and I thought the audience might be as well. So go ahead.
So one example I can give from one of the recent projects is same level. So there was this issue. So there was a predicted issue about the SSD lifetime. The prediction was saying this SSD is reaching I/O will reach the level that I/O, the input and output level, is going to go lower. It was a prediction given by the observability data run by AIOps algorithm, and that was a false positive, because the data they collected wasn't not necessarily from the same region, and the AI algorithm trained based on the data that was more biased to different vendors' hardware. So that the operator NetOps team looked at the insights and said, shall we create a ticket to order new SSDs for this particular rack, or let's look at more and understand why this AI algorithm predicted this. And when they got into and they saw, oh, this data we trained this AI algorithm, observability data, is not necessarily, I would say, correct, or I would say less biased to this vendor. So say they decided not to, but they focus their data collection per vendor domain. So what I'm trying to hint here is, even though each vendor from infra level, platform level, even NAPs have their own observability solution, on top they have their own operational solutions, EMSs, network NMSs, and so on and so forth. I encourage my partners in the field is to have one mindset: collect data as much as you can, stream data, the fresh data, and collect different variety of data from different vendors, and then decide how you're going to use that data with extract, transform, and load ETL pipelines. Then you can massage and make sure that you have really usable data for particular insight tying into your workflows. That's all I can say. Be open-minded, open source, open tools, and enjoy the data.
And I want to thank everyone. We have come to the end. I really want to thank everyone for your contributions, for working well with each other and helping pick up on topics. I want to thank the audience for joining us. And I think, summarizing that last one, if you want the data to be collected correctly, Red Hat says do it yourself. And thanks so much, everyone.